Hi everyone, this is a quick lesson on significant figures. Significant figures tell us how precise our actual physical measurement in either physics or chemistry is. You can't simply put down as an answer the number of digits that are shown on your calculator because how many digits you put down indicate how precisely you did your measurement. And so there are a set of rules that take a little getting used to, but they're not too hard, that tell you how many digits you should write an answer to. So we're going to learn those rules in the next few minutes. Let's take a quick example. Let's say we have this green rectangle and it has a width of 7.428 meters. Now it has a height of 3 meters. Well, you can see that the width of 7.428 meters was measured to 1/1000th of a meter, that's 1 millimeter, while the height, 3 meters, was only measured to the nearest meter. It wasn't measured nearly as precisely. So if you want the area, you multiply the width times the height, and you get 22.284. But that's misleading. That's a misleading answer because that 3 meters for the height, if you look at the yellow box in the center of the green box, it says that this number could have been anything between 2.5 and 3.499. Both of those would have rounded. 2.5 would have rounded up to 3. 3.499 would have rounded down to 3. So if you multiply 7.428 by those two different numbers, you get two totally different answers. So what we have to do is have a set of rules that determines how many digits we can express our answer to. So if we calculate the area width times height, we get 22.284 meters squared. But this is misleading because it says that the precision of the measurement was 0.001 meters. Since 3 meters is only one significant figure, and we're going to learn that concept here today, we can only express the area as 22.284 rounded to one digit. This means that we must express the area as 20 meters squared. That 2 in the 20 is the only significant figure, and that's how we would have to write the answer properly for the multiplication of those two numbers. So let's learn how significant figures work. Here are the rules for significant figures. Number one, all non-zero digits are significant. Number two, leading zeros in front of the non-zero digits are never significant. Number three, zeros in between non-zero digits are always significant. 4, trailing zeros are significant if there is a decimal point. And 5, if there is not a decimal point, it is uncertain whether the trailing zeros are significant, but officially they are not significant. So let's look at some examples of each of those. So if you take this number, these non-zero digits are significant. Leading zeros in front of the non-zero digits are never significant. Those two zeros there are not significant. Zeros in between non-zero digits are always significant. So that 0 in between the 3 and the 5 is a significant figure. Trailing zeros are significant if there is a decimal point. There is a decimal point in this number, so those two zeros are considered to be significant. And finally, if there is no decimal point, it is uncertain whether the trailing zeros are significant, but officially they are not significant. Okay, so let's do some math with significant figures and find out how this works. In multiplication, the significant figures, we abbreviate that as Sig Figs. We just call those Sig Figs. The Sig Figs that the final answer has are the same number of Sig Figs as the least of the multiplicands. And the multiplicand are simply the two numbers being multiplied. So we multiply these two numbers, 22,305, and it has a decimal point and then a 0, so it's 5 significant figures, and 3.2 is 2 significant figures. So how many significant figures can our answer have? It can only have as many as the least of those, which is 2 significant figures. So when we multiply it on the calculator, we get 7,376. Maybe you have 0.0 as well after that. But only those first two digits are significant. That means the rest of them have to be zeros. One other consideration, though, that's your calculator answer, is that 3 has either got to be rounded up to a 4 or back down to a 3. So you look at the next digit, even though it's not a significant figure, you use that for rounding. So since 7 is greater than 5, using the rules of rounding, that means the 3 goes up to a 4. Therefore, so this digit rounds the 3 up to a 4. So the significant figure answer is 7,400. So because 3.2 has only 2 significant figures, the answer has 2 significant figures. For addition and subtraction, it's a totally different set of rules. For addition and subtraction, the answer should have the same number of digits after the decimal as the least add-in, assuming that it's an addition problem. That's the numbers being added together. So let's say we add 2,305.038, which is 7 significant figures, but we're not counting significant figures now. We're looking at how many places are after the decimal. There's 3 places after the decimal. And then we have 3.2. That's 2 significant figures, but again, we're concerned with how many places after the decimal. Again, the rules for addition, subtraction are different than the ones you just learned for multiplication, division. So that means 3.2 has 1 place after the decimal. So when you add these together, your calculator answer is going to be 2,308.238. However, that answer has to be rounded to 1 place after the decimal. So we use the 3 there that the arrow is pointing to round the 2 either up to a 3 or back down to stay at a 2. And since this digit rounds the 2 down to 2, the significant figure answer is 2,308.2. So because 3.2 has only 1 digit after the decimal, the answer has 1 digit after the decimal and is 5 significant figures. Okay, now we're going to do some mixed operations. For problems with more than one operation, use order of operations, PEMDAS. You remember that from your algebra classes. It's parentheses, and then exponents, and then multiplication, division go together, addition, subtraction go together. Now you keep track of the least significant figure as you do this. It's very important you do not round until you reach your final answer. So PEMDAS, do the multiplication first and then the addition. So in this problem, we are going to, well, first let's count the significant figures. You can see that there they are. So because 4.1 has the least significant figures 2, the answer has 2 significant figures. After you multiply 2.43 times 4.1, because that's the first PEMDAS operation you would do, you get 9.963. You do not round this to 10. You only round at the end of the problem. So there we have the 9.963 plus 6.082. And when we add those together, we see that there's 4 significant figures, and that adds up to 5 significant figures. So when we add those together, because we get 16.045, but because 4.1 in the original problem had the least significant figures too, see we kept track of it, the answer has 2 significant figures. So the answer for this problem is 16. Again, we can't show an answer that shows any more precision of digits than our measurement, than our least precise measurement. And 4.1 was our least precise measurement. Okay, here's one that's got a lot of things wrapped together. So let's try this one. Let's conclude this video with this problem. Okay, so 2 significant figures is the least number in this problem, the 3.6 and the 3.4. So now what we do, PEMDAS says do the division and the multiplication first. So we do those 2 first. And when we do that, our calculator for that division problem gives us this big ugly number. It's about 9 digits long. And then the second part, the multiplication, gives us the 1.1492. Now, You're not supposed to round till the end. Yes, that's the rule. But for all practical purposes, you know you're not going to have 9 significant. So you don't have to deal with this unwieldy number. You could have called it 0.6194. You can see that you have 2 significant figures in the original problem in 2 different places. So your answer cannot have more than 2 significant figures. Okay, but anyway, we're going to go ahead now and do the addition subtraction on this. So it says do not round at this point. Realistically, we could have cut a few digits off of the big long number there. So if we add those numbers up, we end up with 2.220208121. So do the addition and subtraction from left to right. Because this is an addition subtraction, we determine significant figures by the least number of digits after the decimal. This is the number 2.75, which is 2 places after the decimal. So that means initially we have to round. This rounds the answer to 2.22. But the original problem had the numbers 3.6 and 3.4, which have only 2 significant figures, so we have to round down even further. So the final answer is 2.2. And that concludes our brief lesson in significant figures.